Okay. Can you tell me which topic you want?
The
Or if
small signal analysis for BJT, sir.
small signal analysis of the BGT. Do you have any notes or something like that?
No, sir,
From
that's the big note. My like the notes that I gave you, that's the final notes we have, but still for some reason, small signal analysis for BJT is coming.
Okay. Only in your syllabus it's written small signal analysis of BGT, or they have mentioned common emitter, common collector, common base, common emitter with follower, common emitter with follower, something like that. They mentioned.
Oh, they did no, sir, just that small signal analysis.
Okay. Okay. Let's study then. So it means that they are asking everything.
Yeah.
Every configuration. Okay.
I mean, yeah, so basically R pi and RC.
R
R pi and RE, if that makes any sense.
R pi makes sense.
And RE, sir?
RE is also there. That is hybrid parameter. Hybrid.
Yeah.
Yeah. Okay. We can start our discussion. Okay.
Yes, sir.
We can take one circuit, one amplifier, and we will start our discussion. Okay. See, the one concept that is there in small signal analysis, what we take, we make capacitor short circuit, okay, and deactivate every DC source. Okay, deactivate means that suppose we have voltage source. Deactivating with voltage source means that it will get ground, right? And current source will become open. Any doubt?
No, sir.
Okay. 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 There are few things, few parameters that I am giving you. Okay, that is important. Okay, that I am giving you. Okay, let's go through those parameters. Okay. One parameter is small signal transconductance. Okay. Small signal transconductance. Small signal transconductance. Okay. That is GM. Okay. That is denoted by GM, and that formula is IC by VT. Okay. Okay.
Yeah.
That formula is IC by VT. GM is IC by VT. Small signal of BJT, in which we have GM as a small IC by VT, and we have R pi. Okay, R pi, that is VT by IB. Okay, R pi is, it is small signal input resistance between base and emitter. Okay. Apart from that, we have one more parameter, RE. That is nothing but VT by IE. Okay. This is a small signal and this is a base and emitter looking into the base. Looking into the base. This is small signal input resistance between base and emitter looking into emitter. Okay. Apart from that, I am giving their relationship also. R pi is beta plus 1 into Re, R pi and this one relation. And apart from that, we have the relationship between R pi equal to beta by GM also. These are the relations. Okay.
Okay.
Apart from that, we have the output impedance also. Output impedance also, that is RO. It is VA by IC. VA by IC. VA is nothing but VA is called early voltage. Okay, and many times it will be neglected. Okay. Okay. Any doubt in this parameter? These are just in this parameter.
Just how to use them, so I still don't know how to
Right. Yeah. Okay. These are the parameter that we are using it. Okay. So basically, what is small signal parameter? Just take an example. Okay. We will take one circuit, common emitter, and we have to this is your V input, suppose. This is your ground. Suppose this is your AC input. Okay. This is your RC. This is your VCC. Okay. Now, what do you mean by small signal model? A small signal model will do what? A small signal model will, using a small signal model, we will draw one equivalent model of this BJT that is known as a small signal AC model of this BJT. Okay. How can we, you can understand that this is your BJT. Okay. We have one standard model, okay, of this BJT. Okay, and that model we are using to calculate other parameters. Okay, basically we have the many small signal model that first of all we will learn first model, that is hybrid pi model. That is hybrid pi model. Okay, it is the one of the most common and one of the most important model. Okay, in this model, how this model is designed, a BJT will be representing using this circuit. Every BJT we will represent using this circuit. This is nothing but this is base, this is emitter, this is collector, this is your R pi. Okay, here the base current will flow. This is emitter, this is collector, and this is your GM VBE.
So
okay,
this is for NPN as well as PNP?
yeah, NPN as well as for PNP. Only small changes will be happen. Okay, it will be same. Okay.
Yeah.
This is a model that represent a BJT. This is IE, this is IB, and this is your IC. Okay, this is your pi model.
Yeah.
Now, suppose you have this circuit. Just now I told you, you have this circuit. You have input. Okay, you have RC, you have VCC. Okay, this is your base, this is your collector, this is your emitter, and this is ground. Right? This is your small signal. This is your common emitter, right? This is common emitter configuration. This is CE configuration or C amplifier. So basically what we will do, we will use this model. Okay.
Why is it called common emitter, sir?
Sorry?
Oh, because the base and the
no, collector is always there. Collector is always at this point.
No, I'm saying, why is it called a common emitter?
Yeah, it is called as common emitter because we are giving input. We are taking output from collector to emitter. We are taking output from collector. Okay. And we are giving input from base. So what is left as a common emitter or not?
Yeah.
Okay. So that's why it is known as common emitter. It means that it is coming in both both case, in both side, when we are sending input or when we are taking output, in both case it is coming. Okay, any doubt?
No, sir.
Okay, so we will see our common emitter model. Okay, and here one thing also there, R naught is also there. Okay, R naught is also there. This, now we will transfer our circuit to this model. How to transfer this circuit? We will write this model as it is. Okay, we will write this model as it is. GMVB R naught emitter R pi. Okay, this is my standard model. Now what we will do, you can see this is our base, right? This is our base, this is our collector, and this was emitter. Now I told you that to draw a small signal AC model, we have to ground our every DC source. Okay, and this is our input, this is our AC input, so there is no need to ground it. Okay, if we are grounding AC DC source, it means that we will ground our VCC, right or wrong?
Yeah.
This is our base, this is collector, and this is emitter.
Mhm.
Now you can see we have this model till here, till BJT. We have input between base and ground, right? We have input between base and ground, and from collector to ground, we have one RC, right or wrong?
Right.
Okay, we have one RC. Now this is your small signal equivalent model.
Got it.
Any doubt?
No, sir. Actually,
Okay.
sir, one doubt. I'm still not completely sure why it's called a common emitter amplifier. I'm very sorry, sir. I still don't.
Okay, yeah. We can take them. See, in our BJT, what we have? Base, emitter, and collector, right or wrong?
Correct, sir. Correct.
Correct. Okay. If I am sending input between base, and if my input is connected between base and emitter,
Right.
and output we are taking between collector and emitter, then it is known as common emitter, because emitter is common in both input. Input where? Input is between which node?
Oh, okay.
Base and emitter, right?
Right.
And output we are taking between collector and emitter, right or wrong?
Yeah.
Okay.
Yep.
Now take another case. Now I am talking about another case that we have base, okay, and we have emitter here.
Right.
Okay, emitter here, and we are giving, and we are taking output from here, and we are giving input from here. Okay, this is your collector that is left out. So this will be common
Common base.
collector.
Wait, common collector how so? We are giving input and output from. Oh no, output is common collect. Wait.
Just as simply you can say it, whichever left out. Okay, there are three nodes, right? Base, emitter, collector, right? And we have two supplies, input and output, right or wrong?
Yeah.
So whichever is left out, that will be the configuration.
But
Okay.
sir, in common emitter, emitter is not left out.
No. See, emitter is common. Here also collector will be common. We will ground the collector, and we will tell that we are taking input, we are taking output between emitter and collector. It's like that. Okay. You will see many cases like that. If I will put one register here,
Right.
then what you will tell? Still it will be common emitter, because you are giving input to base and taking output from collector. Okay.
Okay, got it.
Just think like that. Whatever is left out, that is the configuration. Don't make it complex. Okay.
Yeah.
Okay. Is it making sense to you?
Yes, sir.
Okay. Here just think like that. If we are
No,
giving,
sir, we becomes clear completely.
Yeah, if I'm giving V input here, okay, and
Yeah.
taking V output from collector,
Then it's common base.
okay, and we are grounding base,
In common base.
it will be common base, right?
Got it, got it, got it, got it, got it.
Okay, till now it's okay, right?
Yeah.
But the job is not as simple as that we are seeing it. Okay, if they are asking a small signal model, it means that they are asking you, or they're expecting you to derive voltage gain,
Yeah.
input impedance, current gain, and output impedance. Okay, it is not like that you can just directly draw the circuit and your job is over. No, that is only 10% of your job. 90% and the conceptual part and important part is this one. Okay, we will take up example for one of the circuit in this class, and we will try to derive all these parameters. Okay, later on you can do the work, do some exercises, and if you will get any doubt you can ask me.
Okay, sir.
Okay, because the derivation part will take some time.
Yeah.
Okay. Okay, I'm just taking one circuit example.
But sir, we haven't talked about RE yet.
We talked about
Where, sir?
RE.
Yeah, no, in the drawing.
Yeah, that will come. See, that will come in. We have the different models. Just now I'm talking about hybrid model. In the hybrid model, RPi come. We have one more model, T model. In that model, RE will come. Okay, in that model, RE come. T model, just since you have asked me, I will just give you the brief introduction of T model also. T model. How does the T models looks like? In T model, we have a one current source. Okay. After that, we have one resistor that is known as RE. This is emitter. This is your base. Okay, and this is your collector. From here, your IC is coming. From here, your IB is coming. From your this is coming. This is your VBE. This is your GMVBE.
And when
This
do you
is
draw RE, sir?
RE. This is
Yeah.
RE.
No, but what is this small signal analysis?
Small signal T model.
Yeah, but like of which circuit?
No, this is standard. This is standard. I don't know which circuit. These are just representing this BJT. Okay.
So there are different ways of representing a BJT. One is a hybrid pi model and one is a T model.
T model, right?
You
Okay.
can choose whichever model you want, right?
Whichever, yeah. And hybrid pi model is very common model. T model is little bit complex.
Okay, so it's not like for a certain circuit we got to use hybrid, and for certain.
No. It's not like that.
Okay,
this
then sir,
model
let's
just you can understand
hybrid.
that this is your BJT. Okay.
Right.
According to your connection, this BJT will be driven into some mode, right? Common emitter, common collector. I will give input here. You will give input here. Our configuration will get changed, right?
Absolutely.
But our models will be same because that model is corresponding to a basic BJT. Okay. Basic BJT independent of any sources and any element.
Yeah.
Okay.
So then let's concentrate on hybrid only then.
Yeah, we should concentrate because hybrid is a very common, very standard model. T model is a little bit not very complex. So even if you ask me, I even didn't study T model.
Perfect, sir. Let's just concentrate on hybrid then.
Hybrid model. Okay. Okay. This is your, I'm giving one example. Okay.
By the way, sir, if it says that the early effect should be ignored, so do we then put an RO?
RO will be infinity.
So we ignore it.
Effect, yeah, it means that RO, if resistance is infinity, we can open circuit it. Okay.
Yeah. So technically, just like don't write it down.
Do you have some questions?
No. Like I have questions in that, but first I want to learn the concept, and I'll go to the question page.
Okay. We can take this example. After that, you can take the questions.
Okay, sir.
Okay. This is your circuit. Okay. Now what is the case? Here they have asked you to draw the small signal model, okay, and find input impedance, output impedance, voltage gain. Okay, we have to find this one. Okay, so what information, what knowledge we have to draw
The small signal.
any small signal model?
Yeah.
Signal model,
Mhm.
capacitor gets short circuited.
Yeah.
Okay, and all DC source, if I'm talking about voltage source,
Is grounded. Yeah.
source is
Grounded.
grounded. Okay, is grounded. Okay, I will redraw my circuit. Okay, I will redraw my circuit.
So can I do it myself once?
Yeah, you can do it. You can do it. Take 1 minute and you can do it. Okay.
Yes, sir. And so early effect should be ignored.
Yeah, you can ignore early effect. First of all, we will start with ignoring early effect. After that, we can take up the cases where we can take up the early effect also.
Okay. Yeah, done, sir. Can I just show you on camera?
Uh, yeah, you can show me, or you can just paste it in the chat box. Any way you want.
Yeah, I'll paste in the chat box.
Okay. Because it's not visible.
sensor.
Yeah, I got it.
Can you see it?
Yeah, I can see it. You've grounded RC and R1, right? And R1 is coming with R2 parallel. Okay. And RS with VS, right? RE, okay. GMVBE, RC. And yeah, everything is right. Only one mistake is there.
What's that?
Everything is right. Let me take a let me tell you. Okay. Okay. See what I told you, that capacitor will get short circuit, right or wrong?
Yes.
Okay. So this will short circuited. This is RS, this is your V input, this is your R2, right? This will get grounded, right? This will get short circuited. This is RL, right? And we are taking output from here. This is RE, just name it RE. Okay. RE. And this capacitor will get short circuit.
Yeah.
Now, if capacitor gets short circuit, so if this overall
Oh,
parameter
no
you
RE.
represented as
There's
a
no
short
RE.
circuit.
Yeah, there's
Okay.
no RE.
So basically, you have just done one small mistake only. Okay. Okay. Any doubt? This is R1, R2, RS, RC. Okay.
But sir, can I ask a question?
Yeah.
Imagine if there was no capacitor there, and we
Then
actually
we will
don't
have
have.
the RE.
Yeah, is there some trick for that? That sometimes when there's an RE, then current doesn't go through RL, or it goes through RL, doesn't go through RE. Is there something like that?
No, it's not like that. There is concept that if we are putting this capacitor that is connected across the RE is known as bypass capacitor. Okay.
Okay.
We are using this RE capacitor to give the negative feedback. Okay. Because of this RE capacitor, if you go into the working, your circuit becomes stable. Okay. And the advantage and the disadvantage of this RE capacitor and the advantage of this capacitor is that it is not decreasing the gain. When I will do the analysis, you will came to know that circuit with RE, circuit without capacitor and circuit with capacitor has the different voltage gain. Okay. Circuit without capacitor will have the lesser voltage gain, and circuit with capacitor will have the more voltage gain.
Fair enough, sir.
Okay.
Fair enough.
That is the difference in the concept. Okay. So you can see this is your what was that? Which VBE,
Yeah.
right? GMVBE, right? GMVBE. Okay. And this is R1 and R2. This is R pi, right? This is R1. R2. RS. This is RC. This is RL. Okay. Here IB will flow. This is your emitter. This is your base. This is your collector. This all is grounded. Any doubt?
No, sir.
And this is your VBE. Okay. And this is your V input. Any doubt?
So where does IC flow? What does it flow with the volt? Where is
IC will
IC?
be there.
Oh, yeah, that was right.
Okay. Now we will start our analysis, right?
Yeah.
input resistance. Okay.
Mhm.
Okay. Can you
Yep.
tell me what is input resistance? Input resistance is nothing but V input by I input, right or wrong?
Yep.
What is your I input? This is your I input,
Yeah.
right? Can I take this register as one register? R.
Yep.
Okay.
Yeah.
Okay. So what I'm doing at the input side, I'm just replacing it. Okay. This I am taking as R, some R. Okay. RB. Okay. And RB, we are defining that RB is R1 parallel R2. Right?
Yeah.
And this is your RS, this is your V input. This is I in and this IB is flowing. Okay. Can you tell me using voltage division what is I in?
What is?
Current division.
What is what, sir?
What is I in?
Oh, IN.
Right.
Yes, sir. I can.
Yeah.
It is let me just give me a second. So it's sorry, it's RS divided by RB parallel to R pi plus RS into sorry, IN. Oh, wait, sorry, sir. IN. Okay. Do I know IB, sir? Based on I have to say IN based on IB.
Yeah, yeah. IB is flowing through the R pi. I want I in terms of IB.
Okay, sir. Just give me a second, sir. I'll tell you.
Yeah, take your time.
So is it R big B divided by R pi parallel to RB into RN IN?
No, let me. Can you tell me IB using current division? What do you mean by current division? Can I tell that IB is nothing but I in RB,
Yeah.
RB plus R pi? Is it current division, right?
Yeah.
If two registers are connected in parallel, then we
Obviously.
can find out the current flowing to one of the register using current division,
Yeah, yeah,
right or
yeah.
wrong?
Yes, sir. Yes, sir. Yes, sir.
Okay, so using this concept, can I tell that I in is nothing but RB plus R pi, I in nothing but RE R pi divided by RB into IB, right?
Yeah.
Right or wrong? Okay, any doubt?
No, sir.
Okay, then V input by I input, we can have. Okay, this is not required. So, yeah, for finding input impedance, can I tell that this RB parallel R pi is something RB parallel R pi? Can I take it like that?
Yes, sir.
Okay. Now suppose this is your RS and this is your RB parallel R pi.
Mhm.
Okay, this is V input, this is RS. Okay. and this is your GMVBE. This is RC. This is RL. Okay. And this is IN, right or wrong?
Right, sir.
Can I tell my input resistance R input is V input by IN? Can I tell?
Yeah. I mean, yeah, that's what we did. Yeah.
Yeah, and what is that? It is RS plus RB parallel R pi or no?
Yeah.
Right or wrong? Not.
Right, sir. Right, sir.
Okay. So in this way, we founded input resistance, right?
Mhm.
Any doubt in this one?
No, sir.
Sorry
No.
for there is no requirement of this. I just confused you. Okay.
Yeah,
I was
yeah. No, it's fair, sir.
yeah
It's fair.
yeah. I was thinking that it might be useful, but
No, no,
it's
it's
not.
fair, sir.
It's circuit become much simpler.
Yeah, that was my first answer only, right? So that's why I gave my first answer as that only. Like,
Okay. Yeah.
that was my first answer in the first
Okay.
place.
Okay. Got it.
Yeah.
Okay. Now can you find voltage gain?
Yes,
Can you
sir.
find voltage gain? Voltage is gain what? AV equal to V output by V in.
Yeah.
Okay.
Yeah.
I'm just writing it as a RB parallel R pi. Okay. It will be similar. This is RS and this is your V input.
So could you do the same for RC RL as well? That'll be easier for me as well.
Right. We can take it as a RL dash. Okay.
Yes, sir.
Here RL dash is RC parallel RL. Okay. This is your RS. This is RB parallel R pi. This is your VBE and this is your V input. Okay. This is your IB. Okay. This is your ground. This is your ZMVBE. Okay.
Yeah. And we're taking that as RB. Okay.
You have to find V output by V input ratio.
So what have you written after RB?
After RB parallel R pi.
Yeah, can you just call it something?
I can call it as an RB dash. Okay. RB dash equal to R pi parallel R.
Done, sir.
Yeah.
So
Can you tell me?
I've got minus GM RB dash into RL dash completely
No,
divided
I
by.
don't want in VB. I don't want in VB. I want in only in terms of resistance.
So I'm telling you in terms of resistance only.
No, but you have the VB, right?
No,
Okay.
I said RB.
Okay, RB you told. Okay. Okay.
Minus GM into RB dash into RL dash divided by RS plus RB dash.
RS plus
RB dash.
no, I don't think it will be answer. Let me show you. What is V output? Can you tell me?
V output is minus GM VBE into RL dash.
Right?
Yeah.
What is V input?
V input is RS plus RB dash divided by RB into VBE.
V input is RS. Can I write RS into RB dash into IB?
Yeah. Yeah.
And what is
Into
IB?
into IB.
IB base current.
So why don't we just use
Yeah, I will use, and I can use IB as a VBE divided by RB dash. Can I tell?
why? No, my question actually was, why don't we just use voltage divider?
Okay, you can use voltage divider. What the
Yeah.
voltage divider? VBE is what? V input into RB dash divided by
RS
RB dash plus
plus
RS,
RS. Yeah, absolutely.
right?
Yeah.
Okay. And you will put these value there, right?
Yeah.
Yeah, your answer was right. Yeah, it was right.
Yeah.
Okay, it was right. Okay,
Yeah.
fine. Very good. Okay, can you tell me current again now?
Current gain. Yeah. Just give me a second. Current gain through beta. Wait. So I can't figure out I out for some reason.
Okay. What will be the I out? Just
Yeah.
I'm redrawing my circuit. Right? And there you have the RC and there you have the RL, right?
Yeah.
What will be the I out? I out will be I flowing to the RL or not?
Yeah.
This thing you agree or not? That this is RB dash. This is RB dash, this is RS, this is V input, and this is I. And this is VB. Okay. And this is I input, sorry. I input is this one. Okay. Can I tell that I output using current division?
Mhm.
Can I tell I output using current division?
It's IRC uh, plus GMVB divided by RL I divide by no, sorry. Actually, sir, go ahead. I don't know what.
Yeah, I out using current division, I out will be GMVBE into RC divided by RC plus RL.
Why GMVBE, sir?
GMVB is current source, right? So GMVB is also flowing there. If I take the GMVB in negative direction, it will be minus GMVB. If minus GMVB is a current source, we have two resistors parallel connected in parallel. What will be the I output? GMVB is current source or not?
Yeah.
So using current division, can I tell that I output is equal to minus GMVB? From here, what current is flowing? Suppose here is I current. Okay, if I current is flowing from here, take it easy like that. This is RC, this is RL, and here I is flowing.
Mhm.
So what you will to tell I output?
Yeah. Then current division of RC divided by RC plus RL. Okay.
Right?
Yeah.
Right or wrong?
Right, sir. Right.
Any doubt in this one?
Also, and IN is basically
And
VN.
I in we can directly write. It is nothing but VBE divided by RB dash. Right or wrong?
Yes, sir.
Okay. Then what is our current gain? Current gain is AI equal to I output by I in, right or wrong?
Yeah.
And what is I output? Minus GM VBE RC divided by RC plus RL into RB dash, right or wrong?
Yes, sir.
And sorry,
I out over IN
yeah,
to my
RC
RB
RC
dash.
plus RL and into VBE divided by RB dash, right? Any doubt?
Just
This divided by this, right?
or sir, what we could have done is just like for RN equal, we could have said VB equals to RB dash into IN, and then just put that into the V inside.
Yes. Yeah. Okay, you can we can same thing is there, right? Same thing is this. So you will be getting ZM RC RB dash divided by RC plus RN. This you will get. This is your current gain.
Yeah.
Any doubt in this one?
No, sir.
RC plus RL. This is your gain. We are left with one parameter only. That is output impedance. Can you tell me what will be the output impedance?
Wouldn't it just be, sir, RC parallel to RL?
Right. It will be parallel to RC parallel RL.
Yeah.
Right?
Yeah.
Output impedance will be
RC.
RC parallel R.
Yeah.
Okay.
Yes, sir.
This is one of the most simplest circuit.
Yeah.
Okay. But yeah, it's very good at 95% thing you did by yourself. So I'm damn sure that you can get the other circuit also. Okay.
Okay.
Okay, just I'm telling you one more thing, that what is the difference. Just I was talking at the starting. Suppose you have the one circuit, just I will not tell you much. I just wanted to just tell you these things. So this is R1, this is R2, this is RC. Okay. Now we do not have any resistance here. Here capacitor. Okay. We do not have any capacitor here. Okay. Now our circuit will looks like this one. I'm just giving, you can practice it at your home. Okay, I'm just giving you one hint. That is, it is your GMVBE. This will be your RC. Okay, and this will be your RE. Okay, and this will be your R pi. Okay, this will be your R1 parallel R2, RS, V input. Okay, sorry, this will be also grounded. Okay, and we are taking output from this part.
Yeah.
Okay. Now you will see that your input impedance, output impedance, everything, input impedance and voltages gain will get changed. Okay.
Okay.
All things will be get changed. So
Right.
you can try this one. Okay. If you think that you are able to get the result nicely, okay, you can assume that you learned everything. Okay.
May I ask one thing? So RE is considered to be part of input in resistance or output resistance?
No, it's not required that but if you'll find the input impedance, you will see that RA will be coming as a one part of the input impedance. Okay.
Okay.
Because what is your input? Your input is this much, right? If you go to this circuit, it will be include RE also.
Okay.
Okay. If it is including RE, it will also affect your voltage gain and current gain. Okay. Yeah. If you learn this type, so this is in common emitter, we have two type of configuration. Common emitter with bypass capacity, common emitter without bypass. This is common emitter without bypass capacity because we do not have bypass capacity. CE without bypass. Okay. After that, you have the two more configuration, common base and common connector. You can practice those three one. If you're getting any, you can search the result from anywhere. Google. If you can Google it, that what is the common emitter without bypass voltage gain input impedance, you will easily get it. Okay, and you can practice your question paper. If you are getting the good result and fair result, it is well enough. Okay. There will be no issue. Okay, and tell me how can I help you more?
For now, this is good. So I'll keep you updated. So if I need anything, I'll message you.
Right. Okay. When is exam? This exam?
On Friday, sir.
On Friday. Okay. Let me know if it's okay. Then.
Okay.
Okay. Bye.
Bye, sir. Thank you.